Now that you're more familiar with actual equations of lines, now we're going to transform them into lines of best fit. So here are a couple examples of line of best fit. So if you look at the scatter plot, which are the red dots, they kind of go in a certain order when you look at it from left to right. So these ones are going upward. We would call that a positive correlation, which just means that my slope would be a positive answer. If you look at this one, as you're going from left to right, the red dots are getting lower and lower. We call that a negative correlation. And that means that my slope would be a negative answer. But then look at this one. You're going from left to right, and they're all about on top of each other, and then they go here. Or like, okay, they're coming down. Oh, and now they're going up. Since there's no rhyme or reason, we would call this no correlation, which means no slope can be found, which means we're not going to write a line of best fit. Now, how do we come up with our line of best fits? One is we're going to create a scatter plot, and those are the red dots. And that's where you just plot your data. Then you're going to sketch a line that's most closely appears to follow the trend. We're going to try and have as many points above and below the line as possible. That's not always the case, but let's look at this one up here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So about even here. Over here we got 1, 2, 3, 1, 2, 3, and then there's 2 on the line. Sometimes your line that you draw goes on top of the points, and sometimes they don't. It doesn't even matter. We just try to get as close to all the points as we can. Now here is where our last video comes in. Choose 2 points on your line. Not necessarily the points you plotted, just on the actual line itself. And we're just going to estimate the coordinates. We're going to try and come up with a logical number, as close to probably a whole number as we can. And then we are going to write our equation using our 2 points and our slope. So let's take a look at this one. The table shows the femur lengths, which is going to be x in centimeters. First of all, do they show a linear relationship? We won't know that until we graph them. If so, if it does, when we get done graphing it, let's look at it. If it does show a linear, which means they look like they're going in a line, we're going to write the equation of the line of best fit, and then we're going to use that equation to answer this question. So let's take a look here. So your data points for the x-axis are going to go all the way up to, it looks like 50, and the smallest is 32. All right, and then the height, y, let me see, the highest is about 195, it looks like, and the smallest is in the 140s. Forgive me if I'm not nice and straight. I don't have a ruler in this program. All right, so since we're not starting to write at 0, we're gonna go ahead and label this point right here 0, 0. Okay, 0 on the x, 0 on the y. But we're gonna do a break, so we're gonna be like, we're not gonna go by like 5s, 10s, 15s. So instead, we're gonna jump all the way up to, let's say, 30 here. And then we want to go through 50. And then we're going to label this. This along the the x-axis is called the femur length in centimeters. All right, so the y values, which is the height, let's go ahead and draw that. Height in centimeters. And again, our highest is in the 190s. We don't want to start at 0, so we're going to do a break. And let's say that we start at, looks like 141 is our smallest. So we'll label this 140. And we need to get all the way up into about the 200. So let's see. That'd be 150, 60, 70, 80, 90, 100. Okay. So then that's 150, 160, 170, 180, 190, 200. All right, so 40 and 170. 45, 42, 44, 45, and 183. $32 here and 151. 150 and 195. 37, 32, 34, 36, 37, and 162. 41 and 174. 30 and 141. 34, 32, 34, and 151. Oops, the other one, I did this one wrong. 30 and 141. No, those are right. 47, 42, 44, 46, 47, and 185. And then 45, 42, 44, 45, and 182. Which is right, they were right next to each other. All right, so the question here is, does this show a linear relationship? Yes. So now we're going to try and draw a line of best fit. I'm going to try and do this as straight as possible without a ruler here. Close enough. All right, so now we're going to pick 2 points that are on this red line. It doesn't have to be actual green points. Pick any 2 points. Well, this one looks like it hits exactly. And that's going to be at 40 and 170. And maybe that one, which is 42 for 45 and 182. All right, so we're going to go ahead and find the slope. y2 minus y1 over x2 minus x1. That can't be reduced, so we're just going to leave it as 12/5. Then we're going to pick a point. I'm going to go ahead and pick this one. And I'm going to choose to pick point slope. So y minus my y coordinate equals my slope, x minus my x coordinate. So now I'm going to go ahead and distribute. And then I'm going to solve for y. So we'll add 170, add 170. Okay, so now we're going to use this equation. So this equation is supposed to model the trend here. Okay? So we're going to use this equation now to figure out, estimate the height of a person whose femur is 35. So which value do I plug 35 into? Remember, that's your femur. Do I have to plug that into the x or the y? That's why you always should keep track of what you label. Okay, that would be your x. So now we're going to go 12/5 times 35 plus 74. So that would give me 7. 7 times 12 would be 84. 84 plus 74 is 158. And then I always tell people, go back and look at your graph and see if that kind of makes sense. So go about where what 35 would be and go up. Is it around 158? So 32, here's 35. If I go up and go over, oh, is that about 158? That'd be really close.